Like talking about digital music, and there's some number. We have the normal numbers, decimal, and decimals, and then we also have binary. Wait a minute, decimal, this, binary, and I take hexadecimal. Decimals, this could be 1, 2, 3, 4. Binary is, I think it's some zeros here, makes 5, 1, 1, 1, 1. And 2 is 0, 0, 0, 1, 1. No, 1, 0. And 3 is 0, 0, 0, 1, 1. And 4 is 0, 0, 1, 0, 0. And this is 1, 0, 1, and 2 is 4. And yes, and so on. And 255, for instance, 255 in the binary could be is 100, 1 is 2, 7, 2, 8, 2, 3, 4, 5, 6, 7, 8. It's 8 numbers. It's 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And 1, 2, 3, 4, 5, 6, 7, 8. And it gives 220, 255. And then 256 is 0. It's a 1 and 1, 2, 3, 4, 5, 6, 7, 8 zeros. And in the hexadecimal, for instance, we have from 0, 1, 2, 9, A, B, C, D, E, and F, and then it's 10. So it's 16 numbers here, and then 10 is 16 in our system. So FF means 215 times 16 plus 15. It makes 255. And if FF, let's take this, 15 times 16 second squared plus 15 times second, 16 plus 15, a hexadecimal, is 3,000, is 4,095, I think. Yes. Okay. Yes. And then we can, there's some bits, we call a number representation of bits. For example, 0 and 1 is 1 bits. And in bits, b bits is from none to b minus 1. Sorry. Come on. Come on! Yes. To b minus 1. So 4 bits is from 0. It can represent the integers, positive integers from 0 to 15. Yes. Yeah. And so on. We can make some what's called 16. We have some 4 bits. We have some nibbles. Nibble is one. It's called one nibble is called yes, hexadecimal. 8 bits, 2 hexadecimal, and so on. Yes. And yes, okay. We can have signed integers. So bits, for instance, from minus 128 to plus 127 is 256 different things and needs 8. B is 8. Yes, okay. So we have minus 128 is, you can put this 3, 4, 5, 6, I think it's 7 numbers. Yes, 7 into 10. Yeah, and 127 is 1, 1, 1, 1, 1, 1, 1, 1. No, it's 0, 1, 1, 1, 1, 1, 1, 1. Yes. Okay. Analog to digital. That's what it's about. And it's a ADC converter and so on. We have some need some sampling rate T, sampling rate 1 divided by T, and the sampling rates is Nyquist. The sampling rate Fs should be at least the double of the frequency if it should fit. Yeah, and T is the period between two. Yeah, one here, one here, one here, one here, one here, one here. So period here, T here, and T here, and so on. Yeah, okay. And yes, and we also need a number of bits. It shows up that the number of, yeah, we have that number of bits is a SNR ratio. Come on, SNR in dB. It shows up that it is about 6 times the number of bits. So if we have a range from 20 decibels to 110 decibel SPL, so you need 16 bits. And this is a good number. 2 raised to is so this more than this 44,100 hertz. Okay. Yes. So it fits with 16 bits. So we have here, yeah, some yes, 2 kilohertz, and here we have maybe 20 hertz, and then we have the 1K here, and we have 120 decibels here, and about 0 here. Yeah. Yeah. Okay. Yes, and then I continue with some Nyquist. We have some, it's a little bit technical stuff, but we need some frequency here. We have some Fs half, and we have some decibels here, frequency, decibels, frequencies. We have here, this should be the cutoff frequency. There are many words in -3 dBs here, and then we have a transition rate, region, and then a stop band. Okay. Yes. Got. Yes. And this, all those things should be less than the half of the Nyquist of the sampling rate. Yes. Okay. Yeah, some MIDI is some technical is music instrumental digital interface, and you can do a lot of things with this. I will not talk about it. I have no experience with it. There are some numbers, for instance, PC numbers 1 to 8, and guitar I think it's 25 to 32, and so on. And yeah, timbre and everything you can make. Okay, then we have some analog to. There's some, so I understand it, analog, and we have a ADC, and then we have a digital processing. Then we have a DAC, and then we have a analog again, analog filter. The first one is coming in. The first one is called anti-alias filter, and this is called a reconstruction filter. So it's something about you make it from analog input to a filtered analog, and then you make it to a digital. After this, you get to a digitized input, and comes here, and a digitized output here, output, D input, and after this you get you come to the D output, and you get an to DAC, and you get an analog. And this filter here, last filter here, has to, it's called a reconstruction filter, is to have you have to remove some frequencies. Nyquist, you have to be in to be comply the Nyquist theory, and that is as reconstruction filter is needed to avoid discontinuity. Reconstruction, avoid discontinuity. So that's it what I want to talk about. Thank you.